Time for a pop quiz. Easy as pie.
If you're ready, we'll maneuver. Reaching out. There is no place and no moment in history where I could stand and say, Old British begins here, now.
Okay, there we go. Hi everyone, welcome on in. Due to the great crash of 2025 last night, everything has had to be reset on my computer. So I think everything is okay now. We got the mic hook back up, we got the music. I think I got the laptop hooked back up. So we're good to go. We're here for day 3 of machine learning. And we're gonna get started right away. Hope you're all doing well on this beautiful Friday morning. I'm doing fantastically. I went outside today, trimmed a bunch of tomatoes, plucked off a bunch of beans, and then I came inside and did all my administrative work. I have a little bit more to do, but I can do that later. But hoping to get back out into the garden after I'm done machine learning. So let me turn the music down. We'll do a final check and make sure everything's looking good. I think everything's looking fine. Spotify working again. Oh, KNN, I'd like to know about K nearest neighbors. Oh, KNN. Oh, KNN. So the last time we had actually finished working with the CV methods, right? Our cross-validation methods. So we had done, I think leave one out was one of the methods. We did the hold out method. And then we did the, what was the other one? K-folds cross-validation. So I haven't had a chance yet to actually like break apart the scripts and upload the scripts, but I am hoping to do that at some point over the weekend today, now that things are dying down scheduling-wise. And then we talked a little bit at the end of the last session about hyperparameters. So trying to figure out what value that we should use for KNN. K is a hyperparameter. It's not something that we can... I think they're saying it's not something we can estimate from the data that's given to us, so we have to use other methods to try to figure out how to find the optimal value for the hyperparameter. Dutifully flips to page 29, yeah, or page 79. Yep, that's where we're at. So, and it looked like this was going to be a little bit more of coding in R. So I wanted to kind of start that fresh today, so that I hate kind of working through a chapter and kind of like stopping my coding somewhere, because then I feel like by the time I come back next week, I'm not going to remember. So let's do it. Let's apply hyperparameter tuning to optimize the value of K. An approach we could follow would be to build models with different values of K, right? And they're saying that there are different ways to do that, but nothing that our intuition says is super helpful, right? Pick a sensible or default value. It's a bad idea. Manually try a few different values. This is a bit better. Or use a procedure called hyperparameter tuning to automate your process. So we did talk about that last week. So they're saying an approach we could follow would be to build models with different values of K using our full data set, pass the data back through the model, and see which value of K gives us the best performance. That seems reasonable. This is bad practice, though, because there's a large chance we'll get a value of K that overfits. Yeah, okay, right. So it's the bias variance trade-off that they're talking about here. So once again, we rely on cross-validation to help us guard against overfitting. Interesting. The first thing we need to do is define a range of values over which MLR will try when tuning K. It does feel like K-hack, yeah. K-hacking. It does kind of feel like that, doesn't it? The first thing we need to do is define a range of values. So KNN parameter space, make parameter set, make discrete parameter K values from 1 to 10. Okay, well, we have our script from before. I'm just going to go ahead and make a little note for myself. So hyper tuning, hyperparameter tuning. Parameter tuning for K. That is that is such an outrageous name for this variable or list or whatever the heck we're doing. So it's a make param set, make model multiple, what? Make param set. Okay, we'll just hope that it's actually a function that I can that I can use. Make discrete param. Throw K in there, and we need values equals 1 to 1. Not 1 to 100, 1 to 10. Okay, does that work? Could not find, maybe that's because I haven't loaded a bunch of stuff. Give me a hot second here. I probably haven't loaded MLR. I'm probably also going to need to, I just noticed my environment is also empty, so I probably am going to need to reload some data. Yeah. Yeah. That whole library thing, it just gets in the way of what I want to do, right? This just is terrible. Okay, so MLR, tidyverse look like they're open. Let's go ahead, grab our Tibble. It's probably also going to assume that we have some tasks and stuff defined, right? So maybe not. Maybe. I don't know. Let's get a couple things in here. I don't want to train it and on the original stuff. I don't care about the performance. This is holdout method, so fusion matrix, don't care. K-folds, and leave one out. So I think I'm okay. Okay, so that worked. So let's see what they say about these different functions. So the make discrete param function inside the make param set function allows us to specify that the hyperparameter we're going to be tuning is k. Yep, I can see that. And that we want to search the values between 1 and 10. Okay, I can see that. As its name suggests, make discrete param is used to define discrete hyperparameter values, such as k and KNN. But there are also functions that define continuous and logical hyperparameters. That's kind of cool, that we'll explore later. So the make param set function, which is the outermost function, defines the hyperparameter space we defined as a parameter set. And if we wanted to tune more than one hyperparameter, we would simply separate them by commas inside this function. Okay, cool. Next, we define how we want MLR to search the parameter space. There are a few options for this. We're going to use the grid search method. I have no idea what this is. So this is kind of cool. So this is probably the simplest method. It tries every single value in the parameter space when looking for the best performing value. For tuning continuous hyperparameters, or when we're tuning several hyperparameters at once, grid search becomes expensive. So I assume we're searching over an area, and that's probably why it becomes so expensive. So other methods like random search are preferred. Ooh, interesting. So I wonder if this is where some of our calculus methods help. Anyway, I'm gonna hold on to that thought for a second, but something tells me that if you do a random search, it's kind of like Newton's method. You can just pick a random thing, and then you're gonna kind of test and see what the tangent looks like and try to find like the next highest or next lowest thing that you're trying to do, right? So I bet there's some calculus methods for some of these multiple hyperparameters or continuous hyperparameters that become helpful to use. Okay, so you need to do a grid search, make tune control grid. That was, what is, like, make tune control grid. Make tune control grid. And that's it. Unexpected symbol in grid search. Oh, right. It probably doesn't want a space there. So next we define how we're going to cross-validate the tuning procedure, and we're going to use my favorite, repeated k-fold cross-validation. The principle here is that for every value in the parameter space, which are integers 1 to 10, we perform repeated k-fold cross-validation. For each value of k, we take the average performance measures across all the iterations, and we compare it with the average performance measures for all the other values of k we tried. This will hopefully give us the value of k that performs best. Is best literally just the average performance measure? Remember working on your dissertation and running into that a lot? Running into what? Like, just like the process of tuning hyperparameters? Oh, the loading of library. Yeah, seriously. Even just LaTeX, right? And like running LaTeX and having to rerun your code like 4 times just to get the appendices to work. That's why I said, okay, fair, that's fair. Hey, Better Yet, how's it going? Happy Friday. Alright, let's make this a wide boy. Yoop. Okay, so CV for tuning. So this is a make resample description. So we're going to do repeated cross-validation by the looks of it. Folds is 10. Reps is 20. Now we call the tune params function to perform the tuning. Is there anything I need to like note here? I feel like this is pretty straightforward, right? We're going to be hyper tuning K, or tuning K with values 1 to 10 using, so this is the grid search method. Should maybe, so grid search method, which basically just tries everything, right? I'm still trying to figure out what this is doing. This is just setting up the, didn't we actually do this in repeated? One out. Yeah, so method. Okay, so we've used this before. Folds equals 3, reps equals 500. Okay. So that's all we're doing here. So this is our cross-validation. So we're choosing repeated cross-validation. And then we define the tuned value of K. So tune parameters, classification KNN, diabetes task, resampling. Right, I see the CV for tuning. Parameter set KNN parameter space. So it's calling back this. And control equals grid. Oh, this is a capital S. That's gonna. That's fine. I'll do a small s. Remind me to do a small s for this. So tune params. Classification KNN. We have our task, which is the diabetes task. I believe I have that. I believe I reloaded that. This does not require. So resampling is CV for tuning. That's our cross-validation method. I see. So parameter set is our KNN param space. And our control is grid search without capital S. Who's fishing? We were talking about the pains of LaTeX, yes. Holy shit, everyone's here.
I'm Mr. Meeseeks! Look at me!
Hi Gold, how you doing? Hi Sensation, welcome in. Where have I been? No note, Cargon. True. It's been really hard to find me in July. It's been really, well, June too. June and July have been really busy for me. Hi Dexy, how are you? The whole crew's here. Oh damn! Zach just caught a thong. This song still slaps. I'm not like, 2 years later, this song is still great.
Why did you even rope me into this? Because he roped me into this. Well, him over there, he
forgot
roped
about the
me
second.
into this. Well, he roped me into this.
Now we just need to have DZ here to make sure that they get third. It probably hasn't been 2 years. It's probably only been like about a year. I still haven't been able. I think like Suno changed a whole bunch of its API structure, and I can't actually have the AI generated songs do stuff automatically anymore, which is kind of sucks. 464 days. Damn, we're like a year and a half. 645 days. We're coming up to 2 years. That's awesome. Anyway, hope you're all doing well. Thank you for jumping in. Always appreciate the support. Doing some machine learning. We're tuning a hyperparameter right now for our KNN algorithm. I'm learning machine learning. So the first and second arguments are the names of the algorithm, right? Our classification and the task we're applying it to, which was defined a couple weeks ago. We give our CV strategy, our cross-validation strategy, not curriculum vitae, the cross-validation as the resampling argument, okay, that we created. The hyperparameter space we define as par.set, and the search procedure to the control argument. Okay. If we call our tuned k object, we get the best performing value of k equals 7. Okay, let's see. So what kind of output do we get here? So tune result, OP. It's OP, chat. K equals 7. So our MMCE test had a mean of 0. So like around 8%. So that's a 92% accuracy, which is kind of crazy. Okay. So they had a very similar result at about 0.076. So this is calling X, tuned K X7. So this, I guess, just is just two different ways of like finding the information that we need. We can also visualize the tuning process. The result of this code is shown in figure 3.15. Oh, this is kind of cool. So 1, 2, 3, 4, 5, 6, 7. 7 gives the lowest. Okay, well let's see if we can construct that. I think that's interesting to look at. So K tuning data, generate hyperpars, tune K, plot hyperpars effect. So I guess we're pulling the data out of something. Generate hyperpars effect data, tuned K. So what the fuck does this? So this is just what they're calling it. I don't know what this function does, but it's acting on our list. I assume it's a list. Yeah, it's a list of 7. So it must be going in here to grab something from this list. And then this is just the plot, right? So plot hyperpars effect. So this, okay, and then they're giving me a theme. All right, here it is. And so similar for us, right? 1, 2, 3, 4, 5 was pretty good. 6, but 7 was the best. 8, 9, 10. Cool. So now we can train our final model using our tuned value of k. So tuned KNN. Make learner class for parse values tuned. Ah, I see. So that's going to call the value from that particular list out and put it here. What were we using before? I think we were putting in a full list, right? So the parameters was the KNN param space, and the KNN param space was, right, all of these particular values that we were trying to test. Right, so now that we know the particular value that we want, we can go back. Oops, I think it's up here. So now that we know the value we want, we can come back and actually do this proper. Okay. Okay, so that's grabbing what we need. This is... doing the training. So now I guess we just grab our... This is symbols wrapping the make learner function. We can make a KNN inside of it. Value of K is the pars. When we train our final model, oh yeah, we train our, yeah, okay. Okay, I feel like I'm a little lost at what's going on, so give me a hot second. KNN is OP? I don't know. The value of K equals 7 apparently is OP. So the train command takes the make learner function as well as the task. Our task shouldn't change down here, right? Our task is the same, but it's taking tuned KNN. Which does have the make learner task inside. So how is ours different up here? I see. So this make learner function had the value set at K is equal to 2 before. So this isn't helpful because what we actually really want is K is equal to 7. So same thing, we start with this, and we give it that value, K is equal to 7. Right, so the only parameter we need to set is K, and it's going to be inside of this particular list. Got it. Okay, so this is now training using this particular model on the task from before. Okay. Diabetes task? Interesting. Yeah, we've been trying to classify. So what is it? We have information of patients, and they can fall into one of 3 categories. They're either not diabetic, they're chemically diabetic, meaning that like they're showing chemical signs, but not like outward signs, and then there's like actual I can't remember exactly the 3, but yeah, something like that. So like they're showing kind of internal signs of diabetes, and then they actually have diabetes, I think. And so the model is trying to predict on data that it hasn't necessarily seen what category these individuals fall into based on some other variables. And again, I'm just trying to kind of talk through what's happening to myself. So we found K was equal to 7. This is KNN clustering, so K nearest neighbors clustering. So that means if I put a data point that I don't know about, and I want to figure out which diabetes class it falls into, I need to look at 7 nearest neighbors. And 7 nearest neighbors gives me the best accuracy for predicting how to classify that new data point. Yeah. Hey fam, how's it going? Frankly though, this model is only good as the data. I feel like KNN is always only ever as good as the data, right? So now when we perform some kind of, okay, including hyperparameter tuning in cross-validation. Now when we perform some kind of pre-processing on our data or model, such as tuning hyperparameters, it's important to include this pre-processing inside the cross-validation so that we cross-validate the whole model training procedure. This takes the form of nested CV, where an inner loop cross-validates different values of our hyperparameter, just as we did, And then the winning hyperparameter value gets passed to an outer CV loop. In the outer cross-validation loop, the winning hyperparameters are used for each fold. Nested CV proceeds like this. Split the data into training and test sets. This can be done using holdout, kfold, or leave one out. This division is called the outer loop. The training set is used to cross-validate each value of our hyperparameter search space using whatever method. This is the inner loop. So the training set is used to cross-validate each value of the hyperparameter, right? So it picks the hyperparameter, and then it goes back to the outer loop, the hyperparameter that gives the best cross-validated performance from each inner loop. From each inner loop is passed to the outer loop. A model is trained on each training set of the outer loop using the best hyperparameter from the inner loop. Oh, interesting. Which means that we could theoretically get different values of k. These models are used to make predictions on their test sets. Oh, that's cool. The average performance metrics of these models across the outer loop are then reported as the estimate for how the model will perform on the unseen data. That makes sense. Okay. If you prefer a graphical explanation, I'm not sure that's going to make it easier to talk about, but yeah, so we give the training set to the model. 1, 2, 3, 4. So this looks like it's doing a 4-fold cross-validation. And then it goes through all of the k values for the KNN process, right? So it's going to do a bunch of stuff for k equals 1. It's going to do a bunch of stuff for k equals 2, etc., until it gets to k equals whatever. The winning k goes back up to the test set. And that's how we determine how to classify that new data value. Cool. And then that test set moves over. Yeah, and then I see. And then it goes through the process again until each chunk of the test set, each chunk of the data set has been a part of the test set. Jeez, that's crazy. That's kind of crazy. In my AI course, in my AI course way back in the day when we went into depth regarding the bias in every data set and the ethics of it all. Yeah, seriously. This is kind of a crazy procedure. I kind of like it. The outer loop is 3-fold. For each fold, inner sets of 4-fold CV are applied. Yeah, I saw that. So using only the training set from the outer loop. The 4-fold cross-validation is used to evaluate the performance of each hyperparameter value or searching. Yeah, the winning value of k is then passed to the outer loop, which then is used. Cool. Can you see that we're cross-validating the whole model building process, including hyperparameter tuning? Yes. What's the purpose of this? Please enlighten me. It validates our entire model building procedure, including the hyperparameter tuning step. The cross-validated performance estimate we get from this procedure should be a good representation of how we expect our model to perform on completely new unseen data. The process is pretty complicated. It doesn't just look complicated, it feels complicated. But it's extremely easy to perform with MLR. I suppose it's just functions that are built into the library. First, we define how we're going to perform the inner and outer CV. I've chosen to perform ordinary k-fold. Are we doing this? Okay, we do have a bunch of stuff already programmed here. So let's see what they're up to. So make resample descript CV. And then they're going to go make resample descript rep CV folds equals 10 reps is 5. So I've chosen to perform ordinary k-fold cross-validation for the inner loop. So it's just going with the default number of stuff. And 10-fold repeated 5 times for the outer loop. Next we make what's called a wrapper, which is basically a learner tied to some pre-processing step. In our case, this is hyperparameter tuning, so we create a tuning wrapper with make tune wrapper. So classification resampling is the inner parameter set KNN parameter space, which was defined earlier, and the control was the grid search that we defined earlier as well. Holy moly. Hi, Major. R, oh my fucking god. Yeah, it is what it is. This is what my college uses for our data science program. We haven't made the upgrade to Python yet. So that's one thing I am doing on the side. I am actually learning how to do some of this stuff in Python on the side. Okay, so what are we trying to... So here we're going to actually try to create... we want the loop structure basically to include... So glad you don't have to use this day to day. I know. I try to prevent myself from having to use R a lot too. It just feels so different from everything else. You're curious as why this is using R instead of Python. Oh yeah, like I picked the textbook that my machine learning courses at the college actually use, in hopes to get a better idea of how the content is being taught in the program. You know, as a department chair, I probably should know a little bit more about some of the content in my courses, and these are kind of core courses. So because we use R, this is the textbook that we kind of are forced to use. I'm sure there are great books with Python. I think Reese... Hasn't Reese done one with Python? And I think, like, obviously, like, I feel like the idea is, like, once I have the general... I feel like that's about a lot of programming. Once I have kind of, like, the general scripts written down, then it's a little easier for me to kind of go back through stuff.
Zeta predictable? Python's fine,
Show is
but
back.
it's just a linear function. Time to explore Zeta algorithms that break boundaries, like calculus on the edge. What's your angle?
Every course I took related to AI used Python. Yeah, Python. I feel like Python's probably just a little bit stronger, but Python's fine, but it's just a linear function. What? Huh? What? What are you talking about, Show? So here we supply the algorithm as the first argument, right? Our classification, and pass our inner cross-validation procedure as the resampling argument. We apply our hyperparameter search space as the parameter.set. And the grid search, right, okay. So everything else is controlled from up above. Okay, so we actually don't even have to write a loop structure at all. It's already done inside of the wrapper. Now that we've defined our inner and outer CV strategies and our tuning wrapper, we run the nested CV procedure. So cross-validation with tuning. Oh, cool, it's doing some shit. So what does the resample... We were doing this back when we were doing our cross-validation stuff, right? So the resample is a command... that takes a learner, a task, a procedure, and output measures. That's what we were doing for the cross-validation up above, right? So whenever I wanted to do cross-validation, we needed the resample command. Now, what do we have down here? So we have the KNN wrapper, which must define the learner. Because what was KNN before? KNN was the learner, right? We have the task, and resampling is actually defined by this. Right. Up here we actually... How did we define the resampling up here? Yeah, so kind of the same idea, right? So we made a resample description, saved that, and then we called it into the function. We didn't have any measures here, so I'm assuming that the measures are just automatically defined as the MMCE in accuracy here. Yeah. No one wants to use R to teach now? Fair. It's kind of a gross program. I feel like I've definitely, like... I feel like I've definitely used better programming languages. But again, it's just trying to get used to the lingo. Getting used to the lingo is a bit weird. Okay, so the first argument is the wrapper, the second argument is the name of the task, and we supply our outer CV strategy as the resampling argument. Now sit back and relax, this could take a while. Sure, once it finishes you can print the average MMCE. Okay, let's take a look at the printout here. So resample result, task was here, learner was attuned. So classification KNN tuned. Aggregate performance was what popped out at the end here, so 0.09. So about 9% misclassification, which gives us about a 91% accuracy. Runtime, if it gives you the runtime, 49.71. So what is it, about a minute? Cool. So your MMCE value will probably be a little different than mine due to the random nature of the validation procedure, but the model is estimated to correctly classify, in their case, 91.4 cases. That's pretty good. It's actually pretty damn good. Okay, so we've created a good model. They're going to say, now what do we do with new data, right? Can we make some predictions about some new stuff? So we have our model and we're free to use it to classify new patients. Let's imagine that some new patients come to the clinic. Okay, so they've given us, I guess, information to input. I'm not going to actually do this in R, but we can just read, I think. So these are the new patients that are coming in. We're putting these new patients in as a tibble, I guess. And they're giving us information about glucose, insulin, and SSPG levels. RStudio for machine learning is an interesting choice. I was forced to use R by the maths department. Yeah, seriously. Everyone is hyper-focused on R right now. What is happening? 91.4 is not amazing. Imagine 10% of patients getting misdiagnosed. Yeah, I mean, I guess we want that as high as possible, but then wouldn't that be overfitting? Okay, so those are our new patients. That seems fine. We can pass these patients into our model and get their predicted diabetes status. Oh, this is a chemical, normal, and overt. Yeah, so they were classified as normal, normal, and overt. Congratulations. Not only have you built your first machine learning model, but we've covered some reasonably complex theory too. In the next chapter, we're going to learn about logistic regression. But first, I want to list the strengths and weaknesses of the K nearest neighbor algorithm. IIRC, what does that mean again? Overfitting is only when you get high accuracy. Oh, if I recall correctly. Overfitting, I see. No, I mean IIRC. Overfitting is only when you get high accuracy on training and low on validation. Hey, caller, welcome in. Hope you had fun. I actually really enjoyed the run last night until my computer exploded. I literally, what happened? Like, I literally walked outside of, like, the Temple of Time and my computer blew up. And it literally hard reset. Like, I had to shut it off. Like, I had to do a hard reset last night. It was crazy. And Zach will vouch for me. When I went to start stream today, even OBS was broken. Studies in 2023 estimated that up to 40% of adults over 30 with type 1 diabetes may have been misdiagnosed with type 2 diabetes. That sucks. Alright, so the strengths of KNN. The algorithm is pretty simple. I think it's fairly straightforward. Yeah. There is no computational cost during the learning process. All of the computation is done during prediction. Okay? Like, done during prediction as in putting a new data point in, looking at the K nearest neighbors and casting votes and figuring out how to classify it. So that's where the expense is. What rookie numbers compared to MODY? What's MODY? I definitely think, caller, I'm definitely going to do another run over the weekend, I think. I'd like to maybe do one Saturday night and do it again. Because I kind of like the idea of doing a bingo, to be honest. It was interesting, because you're focusing on something different than just, like, finishing the game. So it's kind of cool. It makes no assumptions about the data, such as how it's distributed. That's actually kind of important, right? There are no internal assumptions about the data. So that's always a plus. The weakness of the KNN algorithm are, it cannot natively handle categorical variables. They must be recorded or recoded first, or a different distance metric must be used. So I think we had talked about that before, right? When the training set is large, it can be computationally expensive to compute the distance between new data and all the cases in the training set. When the training set is large, it can be expensive to compute the distance between new data and all the cases in the training set. The model can't be interpreted in terms of real-world relationships. Right, all we're doing is predicting something. Prediction accuracy can be strongly impacted by noisy data and outliers. That seems reasonable. Yep. In high-dimensional data sets, KNN tends to perform poorly. This is due to a phenomenon you'll learn about in Chapter 5 called the curse of dimensionality. I think we looked that up last week, didn't we? In brief, in high dimensions, the distances between the cases start to look the same, so finding the nearest neighbors becomes difficult. Oh, and we are left with some exercises. Is this the end of the chapter? This is the end of our chapter. I feel like we should try to do at least one of these exercises. So, load the iris dataset using the data function and build a KNN model to classify its 3 species of iris, including tuning the K hyperparameter. Cross-validate this iris KNN model using nested CV, where the outer CV is holdout with a 2/3 split. Repeat the nested CV as in the previous exercise using 5-fold, non-repeated CV as the outer loop. Which of these methods gives you a more stable MMC estimate when you repeat them? Holy fuck, we should probably try to do this. Okay, I'm gonna open up a new script for this shit, though. So this is chapter 3. Exercise 5. Now we're gonna need to, I'm gonna just erase everything. Get out of here. See you later. Good day. Alright, so the first thing we need is we're going to need our libraries. I don't even... Do I need the tidyverse? I think I just need MLR if we're going to be doing this. We're not really plotting anything, so let's reload MLR. And... I am going to need to grab a tibble, right? So we will need some of this information too. So the data is... where is the iris data set? Is it inside the mclust package? Nope. Where's the iris dataset? Hello? Oh, it's built. I don't even need a package. Oh, okay. Cool. There we go. Sweet. Okay, so it's built into base R. Happy days. Build a KNN model to classify its 3 species of iris, including tuning the K hyperparameter. Build a KNN model to classify. Okay, that's nothing. So we need to define the task and define the learner. So we're going to need this information, right? Whatever, I can leave that there. So, the data is the iris tipple. I do need to figure out what the target is, though. What is our target here? Species, I think, right? We're going to do a classification KNN. Parvals. How many values of K? Oh, it wants us to actually figure out the hyperparameter and not just put it in. Okay. So I think I'm fine with the task. Oh, wait. Warning in make task. Oh, it's a warning. That warning's fine. Bye, better yet. Have to jump. This is definitely one of your favorite subjects. Yeah, it's really cool. I think what I've learned a shit ton already just from doing the KNN algorithm, which is making me both excited and nervous about future algorithms and future models. To be a hipster, I liked it before it came cool. MODY is a rare form of diabetes caused by mutations of in a single gene. About 80 to 90% of people with it are misdiagnosed as type 1 or type 2. Oh, crazy. Huh. That's wild. Okay, so I do need to define the learner. So let's pop back and so what do I need? I need hyperparameter tuning. So I need to define this. And I also need to define the method. So let's do this. I probably need to do this last, right? Oh god. Shit. Okay, we're good. Cut that and pop this down here. Okay, so that's our task. This seems fine. Alright, we're just going to tune for K values between 1 to 10. That seems reasonable. We want the grid search to be this, so I think that's okay. And then yeah, let's take a look at some of the code after we did that. So this is choosing repeated cross-validation. Alright, and then we had to tune everything. So I think we're going to need these as well. Here's the part where I have to do I have to learn some of this stuff. So I like this exercise because it's kind of forcing me to think about some stuff. What do I have to do here? It just says including tuning the K. So I don't need an inner, or like I don't need a nested thing. I just need to tune the hyperparameter and build a model that works. So I'm fine with this. I'm fine with this. So the cross-validation for tuning, I'm fine with this. So tune to K. Classification, the task is going to be the iris task. Resampling are going to be our cross-validation for tuning. The parameter set is defined up here. And our control is defined here. So this should be okay. I hope. Je hope. Okay, result K equals 7 with a 97% accuracy. Don't you love working with the iris data set? It's so ridiculous. Okay, so our KNN make learner classification, par vals, so we just take K equals 7, right? Because that's our best one. Boom. So there's our learner. And then we just need to actually go through the cross-validation procedure to finish off this example, I think, or this question, this exercise. What method should we use? Doesn't really matter, I guess. So we have the learner. Now we need to train. Is it really just a matter of training now? Is that all I'm missing? So KNN diabetes task. That doesn't feel right. So what have we completed here? So we've set up the task. We've hyper-tuned, or we've tuned the hyperparameter to 7. So now I can define the learner with K is equal to 7, knowing that 7 seems to be the best thing. But I still need to go through the procedure of doing something. I probably should use K-folds, right? Or hold it. I guess it doesn't really matter. I just need to use a cross-validation method. what's the resample? The resample is actually going through the process of doing something, right? Now, all of this was... Yeah, okay. So I think I'm going to need... It's coming down to this inner-outer thing again, right? So now that I've tuned the hyperparameter, I have to go back out and use a cross-validation method outside as well. So let's just take k-folds. Okay, so now we actually have to train, right? Okay, so we'll do repeated cross-validation full, so that's fine. Stratify equals true. That seems okay. And then resample learner equals KNN, yes. Task equals the iris task of classifying the species. Resampling is this method, and then sure, we'll have it print out some stuff. So there's our aggregated result. About a 97 mean accuracy and about a 3% mean misclassification error. So I think that's kind of what we need here, right? So that would be our... I think that's the full thing. I feel okay with that. So exercise 6 says cross-validate this iris KNN model using nested cross-validation, where the outer cross-validation is holdout with a 2/3 split. By using a 5-fold non-repeated cross-validation is the outer loop, and then it's asking us to make a comparison. I'm going to grab this as well, and I'm just going to put that here in case I need to call the aggregate totals. So those look fine. Now, what I do want to take a little bit more of a look at is... So I'm happy with all of this. Got it. Okay, so that makes sense. So running the train command gives us the tuned model. Yeah, which, I mean, we should have done this the same thing here, right? I'm just using k equals 7. That was the output from the thing. So I feel okay with that. So this. Oh no, wait. Maybe I didn't train this. Did I do this correctly? Set up the KNN and train using the value of k equals 7. This is probably what I need. What did I do then? What did I actually do? So I think, so this is, I see. So this is setting a couple of things. This is just setting some information about the learner, which I did up top, knowing the correct k value. But then I still have to train the model. What did... What was this? Tuned KNN model. I feel like I'm missing something here. What am I missing here? What is... Something's not clicking. What if I do this? This can get saved, and then I can do this, absolutely. Maybe I've done this already, though. K-fold CV. So I feel like it's probably this. But this is, this must be true too. I must be able to use, am I able to use resample as well? I think there is a solution here. So let's see what the solution says. We need 5. Okay, so target equals species, parameter space, make parameter set. They did 1 to 25. Grid search, that's fine. CV for tuning. Fold send reps 20, fine. Tuned K, great. They found their tuned K. So KNN tuning data, generate hyperpars effect data tuned K. Plot hyperpars effect. I see, so they could look and just double check it. I don't think we need to do that. We could, I guess, but we don't. I don't need to see that. I mean, I'm happy just to take this value. So I think this is the part that I need to look at here. Yeah, so tuned KNN, so set height your hyperparameter, so your learner, your parameter value, and then you're training on the tuned KNN. Giving the iris task. Okay, so what did I mess up on here? So I tried to do another K-fold. In the outer spot, right? when all I really just needed to do is say, oh, I've found the optimal value, I just need to train. Yeah, let me grab that. Oh no, it's in here. So that's fine. Okay. So let's do, I'm going to finish off today looking at exercise 6, which is cross-validate the iris KNN model using nested cross-validation, where the outer cross-validation is holdout with a 2/3 split. So updating this, so what did we use? We used repeated cross-validation. Oops, we're down here. So we gave an inner just as cross-validation. We gave an outer, which was repeated cross-validation. And then we wrapped. So resampling equals inner. Let's grab this and play around with this a little bit and see what we need for exercise 6. I don't see why I couldn't reuse this code again. All they want isn't... They just want me to update the outer cross-validation to hold out with a 2/3 split. So that's fine. Hold out, I think, is the code for this. Yeah, hold out, we just have to give the split. But they want a 2/3. We can probably do stratify equals true, right? Okay, so classification, resampling is our inner. KNN param space. Do we have that up here? Yes. So we're searching 1 to 10. We're doing it as a grid search. Okay. And then resampling using the wrapper, the iris task, and the outer sampling structure, which is the holdout. Okay, so it's giving us our aggregate results. What does it want us to conclude with, though? Cross-validate. So we cross-validated the model. Yeah, I think that's it. I think that's all we want, right? So when we cross-validate the model out here, we're just checking to see how good the model is, and the model's performing pretty well. So I think that's what they want for 6. Let's take a peek. Okay, yeah, so your inner is this, your outer. Okay, stratified, perfect KNN wrapper. Yes, 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 that was fine. Holdout, CV with tuning, so resample the wrapper, the iris task, and their holdout resampling, and then they just grab this information. Okay, cool. It seems a little like... I think what I was getting stuck on was building the model versus doing the outer cross-validation. I think that's what I was getting stuck on in exercise 5. Okay, so let's write this as chapter 3, exercise 6. And then I think exercise 7 is just updating some stuff from chapter 6. So just looking at and comparing some stuff. Using 5-fold non-repeated CV as the outer loop. Which of these methods gives you a more stable MMCE estimate when you repeat them? My guess is probably the 5-fold. Let's see if they've given us an answer to that one. Holdout CV gives more variable estimates of model performance. That is not surprising. Cool, so that's going to finish off chapter 3 for us. So that means we get to start a brand new chapter next week. We will be taking a look at logistic regression and working through logistic regression. Is anybody online right now, by the way? Allow me just to take a quick little peek and see who may or may not be online. Tinker's online. So let's pop over and say hello to him. Thank you again, everyone, for coming and hanging out. As I struggle through machine learning on Friday mornings, much appreciated. Good to see all of you. We're going to go say hi to Tinker. We do have some raid messages if you do want to let him know that we're coming in. There they are. And when are we back next? Maybe tomorrow night for a little bit of Zelda, but otherwise looking at getting back to some gaming stuff Monday evening. I do have some hiring that I have to do on Monday, so I will be busy most of the day. So Monday's going to be a little bit dependent on kind of when I can get back home and boot up blueprints for you guys. But until Monday and or a Saturday cheeky Zelda stream, have a good rest of your weekend, and let's go say hi to Tinker. Bye-bye.